Right, so the kit you'll need, safety glasses first of all. Being in college it's mandatory to do it, especially in the workshop, but it's a good idea when soldering as well to wear safety glasses. Obviously we need a soldering iron. We've got it on the stand here, and I've got a damp sponge as well. Now I'll start it off with safety glasses, so just a little introduction with regard to health and safety. Obviously there is a burn hazard here with a soldering iron. It's very hot, this metal part, so don't pick it up by that part there. Be careful also this, if it's been sitting in the stand for quite a while, it's going to be quite hot down at the bottom, so careful. Keep it well out of way of arms and limbs, and be careful also to not touch the cables, so be mindful of where the cable is as well. You don't want that close to the iron or even someone else's iron or anything like that. So bear that in mind. Also when you're soldering, I'm going to use a little bit of this lead-free solder. So it works perfectly well. You don't need a flux for this stuff with this stuff. So it will work quite nicely. You don't actually need to worry about flux or anything like that. But best thing to do first of all, just use the damp sponge just to clean the tip of the soldering iron off. Now also it's worth mentioning these tips don't like being sanded, so if you see a dirty tip, don't go and rub it with sandpaper because you'll rub the coating off it. So it's a good idea just to get it hot and then just clean it off with a damp sponge like this. Now when I what's called tin the tip, so I add a little bit solder like that, you can see we've got quite a lot of smoke coming off there. Now we use these soldering irons in well ventilated areas, but don't breathe the smoke in. Best not, just hold your breath when you've got a bit of smoke like that. So I'm going to just clean that off as well. So going back, what you need, obviously we've got the solder, the iron, the stand, we've got the kit, and then we also use some snips like these. These particular shaped snips are much better than a small pair of pliers. They just really get into where the bottom of the joint is, and you can snip the legs off, the extra length legs off there. Okay, so first of all, let's just open up this pack. I'm going to just move the iron out of the way so you can see a little bit more. We've got a battery pack here. We've got a bag here where we've got some 2 chips and 2 chip holders. Okay. We've got a bag of resistors and 1 little diode there. Some components have come out of their bag, but that should be in this bag here. Oh, open bag, there you go. So there should be, there's a hole in it, so it's, we've got a micro switch, we've got a 3.5mm jack socket, a ceramic capacitor, an electrolytic capacitor, and an LED. I'm going to just put them all to one side, and we'll start off with the resistors and the diode. There's a good reason to start off with the shortest components first. That is because if you start off with tall components like these ones, it's going to lift the back of the board off like that, off the table, and when you put the little components in, they might not sit straight, they'll fall through the holes. So it's always a good idea to start with the short ones like these resistors. Now as well as this kit, you'll probably want either a multimeter or a colour chart, resistor colour chart to hand, because these individual resistors aren't labelled with their resistance. Now you can cheat a little bit, and you can see there are 5 resistors there. On the PCB everything is labelled as to where it goes. By the way, if you need to consult a slightly bigger picture, a set of instructions, here is the link where you can find the PDF that comes with the Genie project board. Okay, so going back to this, we've got 5 10k resistors. I can tell because we've got 5 and they're all labelled 10k. So I'll start with those. Just be careful not to lose the other stray resistors. So we'll put them out of the way. And I'm just going to thread these through all their relevant holes. Now obviously the component goes this way round and the legs go this way round, so they come out on the silvery bits where you solder them on. Some students haven't got that right, so it's always worth pointing that out to start with. So I'm just going to thread these resistors through like this, one by one. It's always good to do a few components at a time. Don't thread everything through in one go, because you'll just end up with a jungle of wires coming out the other end, and it makes life a lot harder to solder them all. Okay, so I'll turn it around, and like I said, just so that they sit flat onto the board like that. You might even want to use one of the other couple of resistors just to prop it up, although you'll probably find just moving the soldering iron on top of it, it's just going to fall off anyway. So what do? Just sit closer, a little bit closer, so I can get nice and steady. The idea is you want to be able to heat up the pad and the wire, and then offer the solder up to between the two. Don't try and get the solder onto the iron so much and then try and deposit onto the legs. What I'm trying to do is just heat up enough to be able to offer the solder up between the two, and eventually it will just melt in like that, and you should get a nice smooth blob looking like that. If you get a round ball like that, it's not such a good solder joint. You're ideally looking for a nice meniscus, they're called. So the little blob of solder already on the tip is going to help conduct the heat as you warm the pad and the leg up. Then I'm going to just move that in like that and then let go. And it should create a nice smooth joint like that. Now, if Mr. Shaky Hands like me can do it, you should be able to do it quite a lot better than me. It's all about just warming up the pad first and the leg, and then offering the solder up away from the tip and just bringing it up to the two like that. Okay, so when you do a few at a time like this, then get your snips. Careful not to snip too close to the foot, to the base, because you might actually damage the contact like that. And these little tin copper tracks, they're tin on the top, can be quite easily lifted off if you're not careful. So I'm going to just snip it like that. And this, I've just spotted I missed one there, so I'll go back to it. But I'm just cutting at the top of that meniscus, not right through it. You can easily cut it through it, but then you might damage it. So it's a good idea just to snip it at the top of that cone. Now again, this is why you wear safety glasses as well, because you can go flying off like that. Now if you can, when you cut a little batch like that off, just find all those legs and just brush them off to one side like that, just so that they're not going to create any mess, unnecessary mess. So I'm going to just go back and solder that one I missed. And then snip it off. Right, now you go on to the individual resistors, so you'll need to read what they are. Red, red, orange, so that is 2 times 1,000, 22,000. We should have one there. 22k, just that one there. Okay, so work your way through all the individual component resistor colours by either using a chart or a multimeter. It's up to you, whichever you want to use. So 4.7k, 4.7k, the last one there. Okay, and we do exactly the same as before. Feel free to snip off any you've got in the meantime if it's becoming a little bit of a jungle. It makes life a lot easier, snipping the ones that are in the middle of a jungle. So these two I'm going to just finish off. Right, so that's all of the resistors done. I'm now going to put the diode in. Now remember, this one has to go a particular way round. We've got a tiny little black ring around it. And that corresponds to, if you notice here, we've got a line on the 1D, it looks like 1D1, but it's actually a line, the band. So I know that is the negative side. So I'm going to thread that through. And at this point I might want to start putting the slightly taller components in as well. So I might just add the micro switch. Again, it goes a particular way around. So it goes that way rather than that way, but it's fairly obvious the rectangular shape. It's not square, so it won't go in the other way. So I'm going to turn that around, just do those four. Now the capacitor and the LED. So capacitor 1, C1, doesn't matter, this ceramic capacitor. Doesn't matter which way around this goes. But this one, remember the stripe down the side of it denotes its negative side. And you can also see it's got a shorter leg like the LED. So that means the longer leg goes through where it says plus here. If you can just see, bring it into camera. Plus there and minus there. Okay. I might also want to just do the LED as well. Remember the notch and the shorter leg are negative. So if we can just see, need to get that into camera, that goes down there. Pushes in like that. Yeah, the shorter leg and the notch go like that. So hopefully they don't fall out. Now it's a good idea not to have the legs too short because they will actually heat up the component and potentially damage it. So here I want to maybe keep the capacitor with a little bit of height, so it's not right up against the circuit board, because that can actually overheat. If I leave the soldering iron too long, I can damage the capacitor if I heat it up too much. So I might just want to give it a little bit of height. Having just soldered one on, you notice it's got a slight angle like that, so I can then just move that like that, just so that it's nice and level. Now you don't want to do that if you don't want to force these, because you can actually pop the component through and lift the pad off the printed circuit board, which kind of renders it useless. You might have to start again if you damage a component like that, damage a printed circuit board like that. So I'm just going to chop these off as well. And now I've just got the chips to do. Now you notice I've got chips and chip holders. Some students go in and solder them straight in like that. It's not a good idea to do that. Two reasons. First of all, these chip holders will protect the chips from heat damage as I solder them. But secondly, you might further down the line want to actually take the Genie chip, the PIC chip out, and put it in a much smaller circuit board. Consider these project boards as like upload boards. They've got their own circuitry designed with this headphone jack, so you can plug it into a serial or a USB port and upload the file. But if you want to, if you've finished uploading and developing that design, you might want to take the chip out and put it in its own dedicated circuit, which might be much smaller as well. So it's a good idea to be able to remove the chip. So we use these. Now I've just noticed this one's got a slightly bent leg, so it's taking a little bit of difficulty just pushing it in. Now you'll also notice there's a notch corresponding to the notch on the printing there, so we've got a notch on both of these, just so you know which way round it goes, because it's not going to work the wrong way round. So that one there, the notch just goes up to the top there, That one goes in much easier like that. And then we can start soldering these. You might have noticed this wasn't a brand new kit, it had been cannibalised a little bit, and I forgot to mention there should also be a battery snap like this. Now instead of soldering it straight in that way, the trouble is if you do that, after a while of moving around wires on a circuit board that get manhandled, they will snap off after a while. So it's a good idea to thread it in through this hole and then out through the next adjacent big hole like that. Okay, and that will just give it a lot more support where the thin wire solder joint is. So the black one will go through 0 volts, like so, and the red one through plus volts. Now I've actually recycled this battery snap and it's a lot shorter than the one that will come with your kit. But it's the same principle. Thread them through like that and then solder the other ends like that. Okay, and then finally you can push this through and give yourself a little bit more cable. Like I say, you'll have a lot more cable than that, but the same idea. Now these contacts here, the output's Q and the input's A or D, depending if it's analog or digital. You can either solder wires on. This one I've done before. So we've got wires on these ones and you can plug them straight into breadboards. Or these ones here, students have been soldering these terminal blocks, terminal sockets like that. Now the trouble with these is they cover every other hole. So, sorry, it's the other way around. There's twice as many of these as the holes. So you really need to chop alternate ones off if you want them to put the whole lot in. Either that, or you can chop individual ones off like this. So I chop 2 off like that. Try and get an individual one. And then solder them individually in like that. Now that is quite a fiddle doing that. Some people put sellotape over the top. Don't use blue tack because it will melt and then go into the socket and it won't make a very good connection. I personally would just take chop alternate ones off like that so you can get a nice straight line. Obviously when you're doing that, alternate sockets aren't going to do anything, so you need to just see which one corresponds up to these sockets here. Depends which way you want to do it. Obviously if you do it this way, just keep wearing your safety glasses because they can spring off like that. Hit your eyes if you're not careful. So we're going to put those into the Qs. Just so you know as well, the plus volts all share the same line like that. So you can see that track is all the same one. So you don't actually have to have lots of different plus volt ones on here or here. They're all the same contacts, and if you plug it into a breadboard, they can all share the same plus volts rail. So at this point a little bit of tape might be handy to hold them in place, so because these easily fall out. Just like that. You might want to check once you've soldered one that the thing's in straight as well. So just going to do that one there. There you go, that looks alright. So now I should be able to just solder the rest in. Assuming you get all of these little sockets in as well, the final thing you want to do is put the chips in. Obviously make sure you get the right one in which. It's quite hard to see what it is, but that one is Genie 18. Now also just bear in mind where the notch is, so notch there to notch there. Now when you're putting them in, I'll try and do it so you can see, you might find the legs are a little bit wider than the sockets, so just be careful when you push it in, don't force it, 'cause and find you've got one of the legs sticking out of a socket like that. That just sits home like that nicely. Okay, onto the ULN283. Now this is a bank of transistors, so all of the 8 outputs are just slightly amplified enough to power something small like LED or a motor, a small motor that is. Let's try and get it so that you can see what I'm doing. So again, as you can see, these are slightly wider. Can't really see, my hand gets in the way, but let's just try and push it like that. So I'm just pushing the pins to the side and then pushing them down like that. And that's it. Soldering a Genie.